This video is about Lesson 8.2, pages 3 and 4 of your Chapter 8 notes packet. In Lesson 8.1, we were talking about exponent properties involving products. In 8.2, we're going to talk about exponent properties involving quotients. Let's first kind of discover what the property is, much like you did for the products. If we go ahead and write out this quotient as repeated multiplication, a to the fifth power would just be a times a times a times a times a, all divided by a to the third power is a times a times a. Okay, knowing our fraction rules that we can simplify by dividing by common factors, we have at least 3 a's on top and we have 3 a's on the bottom. So we are left with just a times a, which is otherwise known as a squared. Notice, if I look at the numbers, 5 and 3 to get 2, what do I have to do? I have to subtract. Okay, so the property is that if I have some base to a power, so let's say a to the m power divided by that same base to a different power, n, how I figure out the quotient is I keep the base and I subtract the exponents. So a to the m minus n. Okay, so we're going to do this. Example 1, we're going to complete these. And we've also combined using the product properties down here as well. If you want to try them first, you can do these first 4 and stop the video and then check back and see if your answers agree. Make sure that your final work, that you're showing your work using this property. But check back and we'll go from there. Okay, so check your answers. The directions, it said write your answers using exponents, so I left them in exponents. The first one, I'm just keeping the base of 8, and it's raised to the 6th power, 10 minus 4. Make sure on this one you need the parentheses because the base is negative 3, so I want to make sure that all of negative 3 is raised to the 6th power. On the third example, I used my product property first. I added 4 plus 8 is 12, okay, and then I showed my work for my quotient property, and I get 5 to the 5th power. And then remember, when you're multiplying fractions, I can just think of this as 1 times x to the 6th. That's how I ended up with this fraction. And then I used the product or the quotient property and I got x squared. Okay? Similar to what we had with our product, we also can raise a quotient to a power. If I write this out in repeated multiplication, a divided by b all to the 4th power is just a divided by b times a divided by b times a divided by b times a divided by b. Okay, then using my product powers, I have the same base, they're all raised to the 1st power, so that's a to the 4th, and the same thing on the bottom, this is b to the 4th, and that is my answer. So that leads us to the next property, that if we have a quotient raised to a power, it's the same thing as the numerator raised to that power over the denominator raised to that power. Okay, go ahead, pause the video and flip the page. Okay, so the first 2 examples are just straightforward use of the property. I can just raise x to the 7th power and y to the 7th power, and then that is my answer. On the next one, notice the numerator is negative 7, so make sure you have the negative 7 in parentheses all over x squared. Now here it doesn't tell me to write it using exponents, so I'm going to go ahead and simplify. I know what negative 7 squared is. Negative 7 squared is negative 7 times negative 7, which is 49. Okay, so I want to leave it like that. I have 49 divided by x squared. I'm going to leave it as a fraction. Okay, the last examples, I got 2 here. These are a little more complex. If you want to challenge yourself, go ahead and stop the video and try it and then check back. Please make sure that your work is adjusted to look like mine if you make an error, and we'll go from there. Okay, so on this first one, each thing was raised to the power of 3. So I have 4 to the third power. Remember, I'm going to multiply these, so I get x to the 6. On the bottom, I have 5 to the third power and y to the third power. Go ahead and simplify the numbers. 4 to the third is 64. 5 to the third is 125. And then I check, okay? I should have only one term for each variable. So I have only one x term, that's good. Only one y term, that's good. And then 64 over 125. They don't have a common factor, so I can't simplify it anymore. So that's my final answer. Looking at the next one, a squared divided by b raised to the 5th power. I went ahead and did that. I got a to the 10th divided by b to the 5th times the 1 over 2a squared. I multiplied the two fractions and made it one fraction. I get this, and then I notice, look, I have two a terms. I don't want to end up with two a terms, so I have a to the 10th over a squared. I can use my subtraction for the quotient property, sorry. So I get 10 minus 2 is the 8. The 2 is still on the bottom. The b to the 5th is on the bottom. Okay, so your answer, write as one simplified fraction as final answer, and you should have only one of each variable. Okay, so make sure that you never end up with like an a term on the top and the bottom. Here, this would not be fully simplified. Okay, that's it for the notes. Thank you.